operations. I mean, obviously, ÖBB decided to not go for hydrogen. Why do you think that other train operators use hydrogen trains? Where's the difference to the ÖBB use case?
Okay, the ÖBB use case is we have a short range of diesel traction lines, so this means we have no long distance passenger service as diesel traction, it's just in commuter railway. And the second is the profile, the mountain profile of Austria. So you have, if you the most diesel traction going to the mountains, and you are able to rolling back to the main line with a recuperation energy effect. So that's an aspect you have to consider. So it means in a flat long distance line, it makes sense to use hydrogen operation, but in the most part of Austria, it's maybe not necessary.
Okay, thanks a lot for this insight. We have now seen this Stadler train, if we go to Mr. Bernsdorf, in operation in the US actually, or which will be in operation in the US. Are there also projects in Europe you're working on?
Yes, we have 2 projects in Italy on narrow gauge that we're currently working on, in Calabria and in Sardinia.
And what are the main differences from normal gauge to narrow gauge if we consider hydrogen trains?
The inherent difference between narrow gauge train is you have a smaller profile, so you have less volume, less footprint available for putting systems in, and that is an additional challenge really to laying out the vehicle on the fundamental engineering in the first step for the layout. Also, the axle loads tend to be lower on narrow gauge rail, which is also a challenge and restricts you on putting very heavy equipment like traction batteries in abundance into the vehicle.
Maybe a question for my own interest is the drivetrain, this technology. Is it very similar to this Flirt H2, or did you make a lot of? Do you have to make a lot of changes? I mean, regarding fuel cells, refueling, or tank system, and so on.
Fundamentally, the system is very similar. You've got a fuel cell system of a number of fuel cells that really depends on the operational need. That provides a current to the traction converter as is needed. You've got the battery. To me personally, a hydrogen train, as mentioned before, is really a battery train with a hydrogen range extender, and that principle doesn't change. So you need to find the right balance. It is different for every application. And that's an interesting challenge for our engineers. So there's obviously differences in terms of architecture and layout, but the fundamentals, they're the same.
Thanks a lot. Which brings us to the project of DLR, and what I've seen, it's quite comprehensive in terms of testing and so on, what has been made. Is it also planned to bring these technologies to a production or to a product?
Not in this project. So for CAFA, I think it's part of their hydrogen strategy to test such a system and to get it done and know all the challenges that are behind of something like this. As far as I know, they are doing other projects already in France together with other OEMs and other operators. But this train, as it is, was just a demonstrator to show that the concept of such a power pack is possible. And now we are also in the challenge to rebuild it to its original state. So we shall not only show it works, we shall show that it's possible to build it back to the original state.
Interesting. Yeah, as you could see, or Mr. Kometer showed that in the high train project something similar was planned with this diesel electric train to convert it to hydrogen to have some knowledge gains there, but this will be or has to wait for a next project to happen. Actually, it was possible to do that within the high train project. Maybe a question to Bosch. We now show that there is you show that there is a lot of potential in regards of internal combustion engines with hydrogen. Is there already a concrete project with OEMs and customers going on? Is this in the planning stage, or where in the stage of realization is what you showed?
I mentioned that we have quite a lot of activities together with our customers on testing our equipment in first single cylinder testing, and I think it's important to mention that a hydrogen injector is not coming from the shelf, so there is also development work needed, and the first step is combustion development, and there we are in several activities together with our customers. Next step would be on the way to validation, confirming these results on a multi-cylinder engine, and then at the last going into a demonstration phase to also prove in the field that this solution is working. So there are a lot of activities going on, yes.
I see. Do you also plan to retrofit existing engines, or is this really a new development?
Retrofitting engines is also a use case where we look into. And whenever we get an inquiry on that, we look very detailed what are the boundary conditions, and then we decide do we want to step into or not.
I see. One question to Stadler regarding the fuel cell system. Did you also plan or make use of the waste heat from the fuel cell system, or are there any plans regarding this? We heard already there are some energy losses. Mr. Behrendt showed that from the energy introduced, a lot of energy is excess heat actually, which maybe could be used, maybe not in California, but somewhere else. Do you plan to do anything with this, or is this actually not so easy?
Maybe for common understanding, one of the challenges with a fuel cell is compared to a diesel engine, that all the heat generated by the losses, they have to be actively cooled. The diesel engine, they get rid of about half of the heat generated via the exhaust gas, and the efficiency is in the same order of magnitude. So we have to install a lot more cooling. Ballpark figure double the cooling capacity for the same installed power for a fuel cell, and it's not at a very high temperature level. So if you were to make use of the waste heat, it wouldn't be very efficient because you don't have big temperature differences. So we did look into that on a very principal level early in the project as well, and pretty much discarded it for now, mainly also because we neither had the time nor the available spare volume. It's not like a train is, there's an extra room, we don't know what to do with it, we put passengers there. So it's we didn't see a lot of benefit in it, and we didn't go down that path anymore.
Interesting, or thank you. So there is, maybe for the future, there are possibilities, but yeah, well explained why you decided for the current course, or to not include it yet, at least. As far, I already said I saw some other presentations of colleagues from DLR. You did some studies on heat recovery, right?
Yes, in the project we have one thing is WAPTEC Family is analyzing an absorption HVAC machine, which makes cold cold heat stream, or whatever you call it, from the heat, from the waste heat, which is quite challenging because the temperature niveau is quite low for such a system. And my colleagues at DLR, they are thinking about using the waste energy in the hydrogen storages. So you have potential energy of 350 bars, and you need 10 bars at the fuel cells. So you need to get rid of that pressure, and you can use it to create heat or cold in metal hydrates. And if you use two reactors in an exchange process, then you have continuous heat or continuous cold energy. And this is part what we analyzed here, to have really the real hydrogen consumption and put it on our test bench and see how much hot or cold energy could be created. And it's in the level of like 10% of the electric energy you would get as a heat stream, cold or warm in the end.
Interesting.
Still with not too much temperature, that's the problem again.
Yeah, also in the high training project we looked into some possibilities to use this excess heat. It's, as you all said, it's not so easy to do it, but there are some options that may be beneficial for the future. So also Team Pais and Da, Post and we, there was a concept also developed on this issue. You now also already brought us to storage. In our project, the hydrogen is stored in pressure vessels. If we come to hydrogen combustion engines, hydrogen storage also in pressure vessels, or do you also think about other possibilities?
So this packaging of the overall solution is always coming from our customers and end customers. And the technical solutions from a storing perspective that we currently see are two different pressure levels at 350 and 700 bars. Or if we talk about applications, for example, in the power generation segment, there the expectation is that the hydrogen is coming from the infrastructure, future infrastructure.
I see. Maybe one advantage from internal combustion engines over fuel cells, which are used in all the other four trains, is the hydrogen purity. What kind of purity do you need for your hydrogen?
So in general, the purity requirements are lower whenever you talk about usage in the combustion engine. And the criteria that I put on my slides, that are always comparing fuel cell solutions together with ICE solutions, they are very much depending on the boundary conditions that you use to look at it. So I would like to leave this rating at the partners that have to take the decision if they want to go for a fuel cell solution or an internal combustion engine solution.
Okay. So maybe to come back to ÖBB, you had your test runs, so in general, what do you think are the best applications for hydrogen trains?
Okay, in my opinion, the best application for hydrogen trains are long distance services, and for railway tracks, they are not have an electrified system. They have long distance, and they have not how should I say it? Sorry. There's a lot of space. So you have long distance, a lot of space, and long distance between big cities. That, in my opinion, is a use case for hydrogen trains.
So if in Austria, so to say, the lines would be different, then it could be maybe a use case, but it's really depending on the profile of the tracks.
It's depending of the profile, as it's depending on the, for example, also the electricity mix of the power generation. There a huge aspect to have to be considered to make this decision for pro-hydrogen.
I see. Let's come to another question to Stadler. So There was a question asked in the chat. What is the maximum allowed weight for the hydrogen storage system? It's going a bit into the direction. Also, how much hydrogen can be stored on this flirt H2? What is the storage capacity?
The first part, the weight is really determined by the maximum axle load we design for. The bigger challenge were the batteries. If you look at it, they're quite heavy per volume. The fuel cells and the hydrogen tanks, they weren't a big challenge really. On the inventory of the vehicle, I'm not sure if that is a public figure. So it's enough for 2,800 kilometers on a good day.
I see. If a customer would need a higher range, so to say, is that possible within your...
Yeah, we designed it, the power pack, in a way that it can be scaled, it can be made shorter or longer. So we at the moment designed for 3 different steps. The one we built into here is the medium size power pack. You get a small and a large, and it comes in increments of storage volume. The large one would be double the volume as to the small one.
I see. And then, as you said, it's really huge trains until 12. Did I hear that correctly? 12?
That's on the Flirt family.
Okay.
So what we've done, the longest one is for the UK market. That was a 12-car consist. Not Jacobs bogies all the way through. 6 and 6. We've got long ones in Switzerland as well with 8 cars. But we don't see large vehicles like this as the typical application for more niche, low frequency, low customer applications like battery or hydrogen. Typically, again, that's just an average statement, but typically when you have a high customer demand, you have a business case for an overhead power line as well. So the vehicles we are talking about today, hydrogen, touching sometimes on battery as well, they tend to be smaller vehicles. So we are looking at 2 cars, which is the smallest we're doing, up to maybe 4 or 5, something in that range.
I see.
And then you always have, as an operator, have the option to do double traction in peak hours. You put 2 of the vehicles together and you have 1 driver.
I see. Okay. Yeah, thank you for clarifying these options. No, it's quite... I understand. Let's come to the refueling. Also in the DLR project, we saw that there was also a refueling station, or you showed a refueling station. Was the refueling station developed within the project?
Partially. So our partner CNH2, they had parts of it already. So this dispenser container was available. It was from another project where they also, it's also able to refuel at 700 bars. So it has 2 dispensers. And there was an additional storage brought to that existing concept, and we made it for less pressure. In the end, we don't need the 700 bars. We are not able to refuel at 700 bars, so we went down to the 350. Yes, but it was also with other, I don't know, regional funds. They already had other projects, so there was some existing equipment and something on top. It was the most difficult part because here we really had problems in delivery chains. Things didn't work the first time and then you needed a separate part or something like this and you couldn't get it. So this is why we have a delay in the refueling station. There we really came into topics of delivery, supply chain challenges.
I guess everyone here already tried to order a fueling
Exactly.
receptacle and didn't get it. Yeah, this is just one.
And the PLC
one
for this and so on.
And it's also extremely expensive.
Yes.
Yes, you already mentioned. Okay. Regarding the Type 3 storage tank, so you have a metal inliner, aluminium inliner, or
I don't know.
okay.
Type 3 is aluminum.
Do you think
it's metal? I know, but I don't know which metal.
okay? Regarding, do you think this is beneficial in regards to refueling times? Or what was that? Why did you actually decide?
I think it was a question of availability at that time. It wasn't the aim of the project to develop storages, so it was searched for something that is applicable for rail and usable for rail and already available on the market.
I see.
For the refueling, it doesn't make a difference because the standards for refueling limit the vessel temperature to those 85 degrees, and they don't care if it's type 1, type 3, type 4 as far as I know. So we are also limited to those 85 degrees, even if such a storage could handle more temperature.
Well, that of course, we also did a lot of, or we worked a lot on the refueling protocols. So for trains, there are no refueling protocols per se.
Yeah.
And of course, type 1 temperature is not an issue. And as Nusha also mentioned, there was a refueling protocol for this train, or for this high train developed, to refuel within half an hour, especially with a lookup table, and also to the main issue. Of course, you always can refuel fast if you pre-cool, but which costs money. And so the question was, within the target time of 20 to 30 minutes, if we don't pre-cool, when is it feasible? So because there's some money in it, and yeah, it's quite a tricky thing actually, this refueling, and it's for trains not that available yet, but what is for hydrogen on the other?
Yeah, we missed. We don't know exactly on the vehicle side with the storages. I guess you have the same concerns with the temperatures. Then there is no refueling protocol, and also the question of communication between the train and the refueling station could be quite helpful to have a communication, but it needs to be safe in CL4 level in the end. So it's difficult to do all this at the same time.
Did you have communication?
We have no communication. There was a point where it was decided we don't need it. Later on, maybe it would have been better to decide different, but we don't have it. I know that Deutsche Bahn in the H2Go's rail project, which they are currently showing with Siemens, they have a communication.
Maybe for the audience to explain, if you have a communication, you know the temperature inside the tank, and therefore you can refuel faster. If you don't know the temperature within the tank, you have to go with lower speeds in order to be safe. That's just the issue. Why communication is a thing, but since it's not standardized, everyone has to develop an own system. I have one more question for Bosch, or actually two. There was a question if it's also feasible to burn mixtures of fuels. Maybe not. So if one had, or is this something that is considered, or you say, okay, we try to get under control burning pure hydrogen, burning.
Yeah, that's the focus of the today's work. I showed that there are also other alternative fuel candidates, like for example methanol or ammonia. And there it's also in discussion to use hydrogen, a little amount of hydrogen to improve the burning qualities.
And then one last burning. You said burning quality.
Yeah. Important to mention. Let me make one more remark. Is that many hydrogen applications are today natural gas applications, and there it's always possible to use a certain amount of hydrogen together with the natural gas.
I see.
So this would be also an opportunity.
That would also be feasible.
Yeah.
Since it's a combustion engine, you burn at quite high temperature, and there is also always some NOx coming out of it. What are you doing in this regard, or what are the solutions?
Yeah, that's right. And this is also the focus in the combustion development that I mentioned earlier in my answer, that this is the first step to improve and optimize the combustion. And the nitrogen values is for sure something where our customers look in detail at. And when I mentioned that there are 2 plants in Hallein, the second one is providing denoxtronic, and that would mean that you have an exhaust gas treatment afterwards, if the amount of nitrogen is too high.
Okay, so there are also possibilities to work against this. Regarding the fuel cell system which was used in the DLR project, in this train you said it's a Toyota fuel cell, also used in the cars. So it's not a specialized heavy-duty fuel cell. You did a lot of measurements and so on. Is there anything you can say about life expectancies and so on?
These are still under analysis, the real life behavior and the duration, but here we have to rely on the values that are given by Toyota. All I know is in this testing campaign we haven't seen any degradation yet. So it's good, because if we would already see something after this small amount of kilometers, then we would have a problem in the future. But still, it's more or less begin of life condition anyway.
Okay.
Maybe on degradation, what we learned during the project, the biggest problem is impurities, and it depends on the technology of the fuel cell membrane, but they are very sensitive to that. So that can have a really big impact. So hydrogen quality is a big topic, and quality assurance during the daily operation will be a topic. And in my personal view, maybe at the moment a little bit underrated topic still.
It is. I think you're completely right. I have to say that because we are actually currently working on a project called High Quality together with the ÖVGW, that's the Association for Gas, Water and Gas in Austria. How to implement a monitoring and quality assurance system for hydrogen, because in the end we saw in the High Train project, it's then always the question, whose fault is it? And if there is no clear data, I mean it's really a problem for both sides. So it's very important to have this quality of the hydrogen well defined firstly, but also well monitored, and then to see where are the problems, because as far as I also understood from your projects, we are at the very beginning, and regarding lifetime we don't know everything yet, so it's a path that needs to be gone together actually. Quite interesting. Are there any more questions from the audience?
No question, but a remark, you should mention that we are driving hydrogen cars since 10 years here in the Green Energy Center, and have the first hydrogen car in Europe. It was installed here, and we have some experiences with fuel cell, so that there is not the impression that there is nothing in the air about this hydrogen quality and so on. It was one of the first questions in general when we imported the first cars in Europe. Yeah, how the quality of the hydrogen must be. So, and I can remember there were big discussions in Bolzano about this issue, and now we are driving these cars 10 years already. We have more 2 generations of cars here in the center, so we are driving all the day with this hydrogen cars. So it's an input for you as industry, so that this is a very important point from the quality assurance aspect and from the risk management, but on the other hand we can see the cars are driving.
So what I had to learn, I think that was an important point, the cars, they drive, so it's reasonable, it should also work for a train, and that was also, as I say, my personal approach. And what I learned in these last 8 years, we all learned a big train, and that of course in the train it's much more complex because you have those long lifetimes you need to guarantee. The car, okay, if one of 3 or if one of 100 cars breaks, it's reasonable, but for the train it's not an option, it has to go. And if you don't have these big numbers, you have these long durations, it has to work, you have the business cases over 30 years, you have to supply all the maintenance parts, and what we saw in the High Train project with the fuel cell providers, okay, they want to sell volume, and in the train you don't have that, so it's a really not so easy thing with the train and the fuel cells and the hydrogen. But in the end, if all the parameters are correct and if you find the right project, as we saw, can be really an interesting case.
And the operators should know at the end of this day that they cannot sell this via internet, this technology.
Yeah.
So this is one big message which is really for me it's the main issue, because I can see nearly everybody thinks he can sell this in Amazon.
Or buy it on Amazon, right?
Or buy it in Amazon.
Okay, good. So technology is still in the future in some ways, although projects already exist and products already exist. Thank you for giving us this insight and also answering quite detailed questions. Actually, I know that this is not so easy since some or a lot of information is actually quite confidential to all the partners. Then thank you all for participating, everyone who participated online, people participating here, all the speakers of course. It was really nice that everyone made the effort to come here to the Green Energy Center Europe, be in place. I hope we can use now some minutes to also get to know each other better. I also want to thank the team of WIVA for supporting. I want to thank the team of FEN Systems, which was a lot of work to organize this event. All the High Train Consortium partners, of course, and the technical team from Audiwerk also for doing such a nice job with the technical issues. So thanks a lot for everyone attending this knowledge exchange. I hope you learned something, and if there are any questions, and if you want to operate a train, just write, right? info@hightrain.at, and these experts, a lot of knowledge is here. You cannot buy it on Amazon. See you hopefully soon.